let's begin with number 3. We just want to do some long division. This polynomial divided by this one. So we're going to divide x minus 4 into x squared plus x minus 17. Okay, so what do we multiply x by to get x squared? If we multiply it by x. X times x is x squared. X times negative 4 is negative 4x. And we're done with that little piece. And now we're going to do subtraction. X squared minus x squared is 0. X minus a negative 4x is 5x. And we bring down the negative 17. And now we go, we start again. X times what is 5x? X times 5 is 5x. 5 times x is 5x. 5 times negative 4 is negative 20. And we subtract. So 5x minus 5x is 0. Negative 17 minus a negative 20, that's going to be positive 3. So we have a remainder of 3. Okay, but that's not really having done division. What do we get when we divide this by that? Or in other words, what do we multiply by? What do we multiply x minus 4 by in order to get this? Well, remainder 3 it's not really a mathematical thing. It's just kind of telling us that 3 still needs to get divided by x minus 4. So we say that. We divide 3 by x minus 4. So this is what you get when you divide x squared plus x minus 17 by x minus 4. Okay, so this is your actual answer. Next we'll do number 8. I think, yes, number 8. Okay, so I'm just going to, instead of writing this, you can see it in your book, we're going to divide x squared plus 1 into 7x to the third plus 11x squared plus 7x plus 5. It's the same whole process over again. You might notice there's an x squared here and not just an x, and that's okay. We can use long division to divide by anything we want. Synthetic division is not the same story, but long division we can. So what do we multiply x squared by to get 7x to the third? What does it take? It takes 7x to multiply by x squared to get 7x to the third. So we'll just put 7x over here. And then we multiply 7x squared times, or 7x times x squared is 7x to the third. 7x times 1 is 7x. So we're going to put that over here because it lines up with the 7x. Because the next thing we're going to do is subtract. Okay. So we do 7x cubed minus 7x cubed, and we get 0. 11x squared minus nothing. We could put 0x squared here if we wanted to. 11x squared minus nothing is still 11x squared. Then 7x minus 7x is also 0. And then we bring down the 5. So all we really have here is 11x squared plus 5. And then we begin again. X squared times what is 11x squared? Well, 11. 11 times x squared is 11x squared. And 11 times 1 is 11. So just put 11 there. You could put 0 here if we want. Right? So minus, we're going to subtract this. This is 0. That makes sense. 0 minus 0, that's also 0. 5 minus 11 is going to be negative 6. So we have a remainder of negative 6, which really means that 7x plus 11 minus 6 over x squared plus 1, that is what we get when we divide these two things here. We divide this by that. So there is the result. Now we're going to do synthetic division. And remember that the only way you can use synthetic division is if you are dividing by x minus k. Okay, and remember, it doesn't mean that you couldn't see an x plus something. It would just mean if you said x plus something, k would be a negative number. What do you have to subtract in order to make addition? So you have to subtract a negative number. Okay, so now we'll do number 11. You'll notice all of these as you look at them. The highest power of x that you see in the thing you're dividing by is 1. That's another way to look at it. The highest power has to be 1 if you're going to use synthetic division. Okay, so how do we use synthetic division? First, we're going to set up this little L bracket here. And we're trying to divide 2x squared minus 7x plus 10. So we put in the coefficients in the correct order. We have them in order of the powers of x. So we have a 2, a negative 7, and a 10. Those are the coefficients. Out here we're dividing by x minus 5. Right? Yes? So what do we put here? We put a positive 5, whatever we're subtracting here. Or if you look at the whole number, it's the opposite of this number, however you want to think of it. So now we bring down the 2 and begin. 5 times 2 is 10. We add these together and get 3. 5 times 3 is 15. We add these together and get 35. Or 25. Whichever you want. So the result is, we got the remainder of 25 over x minus 5, just like we did with long division. And we have a constant next. That's positive 3. And now we have an x term, so we have 2x. 2x plus 3 plus 25 over x minus 5. That's the result of the long division. Let's do number 18. Yes, 18 is a good one. Here's something you have to be sure that you do with long division, or with synthetic division, because you'll miss steps otherwise. So here is our polynomial, x to the 4th plus 4x to the 3rd plus 16x minus 35. And we want to divide that by x plus 5. Okay. Now, it's kind of tough because you just have to remember that this is what you have to do, because there's not really going to be anything other than getting the wrong answer that's going to tell you did something incorrectly. You'll notice there's no x squared here. So we need to put in a 0x squared, just like we did with synthetic substitution. You got to have that placeholder of a 0. So now we bring down the coefficients. This is a coefficient of 1, then 4, then 0 for how many x squareds there are, then 16, then negative 35. And what do we put out here? We put the opposite of 5, so that's negative 5. And we begin. Negative 5 times 1 is negative 5. 4 minus 5 is negative 1. Negative 5 times negative 1 is positive 5. 0 plus 5 is 5. Negative 5 times 5 is negative 25. 16 minus 25 is negative 9. Negative 5 times negative 9 is positive 45. And negative 35 plus 45 is 10. Okay, so the result, let's start with the remainder and work the other way. The remainder is 10 over x plus 5, and that's positive. Then we have a negative 9 constant. Then we work up to the x term. That's going to be a positive 5x. Then we work our way to the x squared term. That's a negative x squared, just a negative 1x squared. And then we work our way up to the x cubed term, and that's a positive x cubed. So x cubed minus x squared plus 5x minus 9 plus the remainder 10 over x plus 5. And that is some synthetic division. Now we're going to use synthetic division to do something here. Number 21. We have this function. And this factor. They're telling us that this is a factor of this, meaning that x minus 6 times some other polynomial equals x cubed minus 10x squared plus 19x plus 30. Alright, so that's cool that they gave us the factors, like some of the work is done. What they want us to do is find the other factors. So how can we do that? Well, if you've I imagine you most likely noticed that when we divide something with like a third degree by something with a first degree, we wind up getting a smaller degree, and here we would wind up with a second degree. So the result is slightly simpler. It's a smaller degree, right? This was a fourth degree, and the result after division was a third degree. This was a second degree. It wound up being a first degree when we divided, and so on. That's always going to happen. Makes it a little bit simpler, a little more manageable. So if we were to divide x minus 6 into this guy here, we'd wind up with this question mark, and this question mark would be a polynomial of a smaller degree. Maybe we could find factors of that more simple polynomial. So to find this other mystery polynomial, we just divide by x minus 6 on both sides. So then our polynomial would be whatever this is. Right, just bring that down. So can we do this division? Sure we can. We actually have an x minus 6. This is, you know, the highest power is a power of 1. So we could use synthetic division. That makes it all the easier to do this. So we'll bring down the coefficients, make sure we put any zeros in there if necessary. So put a 1, negative 10, then we go down to the x, okay, no zeros yet, and 30, so no zeros were needed. And what do we put here? We're dividing by x minus 6, so we put a positive 6 here, and bring down the 1, and now we're ready to go. 6 times 1 is 6, then we get negative 4, then negative 24, then we get negative 5, and then we get negative 30, and get 0. Of course, this should happen. You should get a 0. If you don't get a 0, what that means is you did something wrong, or this isn't a factor, which means the book is wrong, or you wrote it down wrong. Something's wrong. You must get a 0 here. Because for one thing, by the factor theorem, if this is a factor, then the result, or not the result, the remainder should be 0, has to be 0. Read the remainder theorem, or the factor theorem. The factor theorem says a polynomial, a polynomial, has a factor of x minus k, or in this case, x minus 6, if and only if you put in this guy right here, 6, into the polynomial and get a 0. So this setup is exactly like synthetic substitution. When we put in 6, we had better get 0, otherwise x minus 6 couldn't be a factor. Okay, so the long story short here is when they say this is a factor, if you use synthetic division, you'd better get a 0. Okay. And the next part of the process should make that pretty clear too. Let's see what we get. What's left over here? We get x squared minus 4x minus 5. Okay. So what we're seeing here is that x minus 6 times x squared minus 4x minus 5 is equal to x cubed. It's equal to x cubed minus 10x squared plus 19x plus 30. So what they've asked us to do is they've given us the first factor and asked us to find the rest of the factors, to factor it as much as possible. So can we find the factors of x squared minus 4x minus 5? Of course we can. What multiplies to make a negative 5 and adds to make negative 4? How about 1 and negative 5? That works. So x minus 6 times x squared minus 4x minus 5 equals the original polynomial. And we factor this, it's equivalent. If we multiply this out, we would get this. So now we have factored out this completely. If we were to multiply all three of these out, we should get x cubed minus 10x squared plus 19x plus 30. Okay, so divide out the given factor. That means you should get a 0 as the remainder. Now you'll get the result of that division. here it is. You factor that even further, and now you found the rest of the factors. Let's do that again. We'll do that for number 28. F of x equals 3x cubed minus 2x squared minus 61x minus 20. And they're saying that a given factor is x minus 5. So let's divide out this factor of x minus 5, and then we'll factor the simplified results. So we'll set up the synthetic division. We got 3 here, negative 2, negative 61, and negative 20. No 0 placeholders are necessary. Put a positive 5 here. And we begin. 5 times 3 is 15. 15 minus 2 is 13. 5 times 13 is, let's see, 65. And 65 minus 61 is 4. 5 times 4 is 20. Negative 20 plus 20 is 0. Make sure you get that 0 at the end. It's crucial. If you don't get it, go back and check your work. Make sure you didn't write something down wrong in the original question, or that you didn't do some arithmetic wrong. Like here, 5 times 13. Prime opportunity to make a mistake if you're doing it in my head. If you're doing it in your head, if I'm doing it in my head, that arithmetic that seems really simple, it could trip you up. So if you don't get a 0, just go back and check for mistakes. So what did we get from that? We got that this divided by that is 3x squared plus 13x plus 4. Okay, so that means that x minus 5 times this equals the original. Alright, and we just want to factor this further. It just says find the rest of the factors. Okay, how do we factor something like that? Well, it's got a coefficient out in front of x squared that's not 1, so that's where we use this little x thing here. 3 times 4 is 12, and then we put 13 down here. What multiplies to 12 and adds to 13? How about 12 and 1? So we get x minus 5 times, here's this work we're doing in red, 3x squared plus x plus 12x plus 4. Group these two groups. X minus 5 times, okay, what do these two have in common? Just a simple x. So we get 3x plus 1. What do these two have in common? They have a 4 in common. And we get 3x plus 1, as we know we should get this exact same thing. And we get x minus 5 times 3x plus 1, that's that common factor that we're taking out, times x plus 4. Right, and we're factored. Everything is factored all the way. We found the other two factors. They are 3x plus 1 and x plus 4. And now we move on to zeros. Number 29. They give us this function. It's x cubed minus 2x squared minus 21x minus 18. And then they give this number to us, this number negative 3. What is the negative 3? It's a 0. Okay, if you've forgotten what the term 0 means, it means if we take negative 3 and put it into this function, we will get a 0. The whole thing will work out to be 0. Okay, well, what if we set up this synthetic thing here? Whether we look at this as synthetic division, synthetic substitution, whatever the case may be, we're saying that if we put negative 3 into the function, we should get 0. Okay? We should wind up getting 0 at the very end. Remember synthetic substitution. We would do all that work and then wind up getting the, whatever we're supposed to get when we plug this into here. This into there. So let's do that, and we should wind up with a 0. And then we'll wind up with this guy right here, a simpler polynomial that we'll keep working with from there. So bring down the 1. Negative 3 times 1 is negative 3. Negative 5. Negative 3 times negative 5 is positive 15. And 15 minus 21 is a negative 6. And negative 3 times negative 6 is positive 18, and that is a 0 indeed. Okay. So we'll draw the same implications that we did just a second ago from the problems that we just did, numbers 21 and 28, when we were looking for other factors. Right? We know that x plus 3, right, because that's, since we put a negative 3 here, that means it would have come from a factor of x plus 3, times x squared minus 5x minus 6, it must be equal to this polynomial here, right? Okay. If we put a negative 3 in here, this will be 0, and 0 times this will be 0. So negative 3 is a 0 of this here, which is equivalent to this original polynomial. So if we want to find the rest of the zeros, we then just need to find the zeros of this guy right here. Right? So to find the zeros of this guy right here, we will factor it. It's a simple factoring problem. That'll be x plus 1 and x minus 6. Right? And we'll set that equal to 0. And so x plus 1 has to be equal to 0, or x minus 6 has to be equal to 0. So x is negative 1, or x is equal to 6. So if we want to find the rest of the zeros of this polynomial, which is what they ask us to do, we can use the given 0 and say, well, I know that if I use synthetic division, I can divide out and make a simpler polynomial that I can then find the zeros of, and those zeros will be the rest of the zeros of this polynomial, right? Because, as we talked about, when we do the synthetic division, that means that the original divisor, x plus 3, times the result should be equal to the original polynomial. Right? So to find the zeros of this guy right here, would be the same to find the zeros of this polynomial, which is just these two multiplied together. Well, the 0 of this is very easy. You just put a negative 3 in there, you get 0. And then we'll find the zeros of this polynomial, which is just a quadratic, which is simply factored, and we find the zeros quickly. And since this was a factor of the original polynomial, it would have the same zeros. If I put a negative 1 in here, what we're saying is that we'll get a 0. And if we get a 0 on this side, we should get a 0 on this side because they're the exact same thing. So let's do another where we find some zeros. Number 34. f of x equals 5x cubed minus x squared minus 18x plus 8. And they're saying that negative 2 is a 0. They're saying that if you put negative 2 into this polynomial, you will get a 0. So we should, if we do synthetic substitution, synthetic division, they're the exact same process, we should get a 0. Okay, no zeros, placeholders are needed. They're saying we should be able to put a negative 2 in here and get 0. So that's what we are going to test out here. So bring down a 5, we get negative 10 here, negative 11, and we get positive 22, and then we get 22 minus 18 is a 4, and negative 2 times 4 is negative 8, and we do get a 0. That's exactly what we should get. And so now we can conclude that since negative 2 is what we used for the synthetic division, it came from a factor of x plus 2. If we multiply that by the result here, 5x squared minus 11x plus 4, that should be equal to the original polynomial, 5x to the third minus x squared minus 18 plus 8. Okay, so if we want to find the rest of the zeros of this polynomial, we do have a 0 of negative 2, that's a given. Let's find the zeros of this quadratic, and that'll be the remaining two zeros of this polynomial. So we'll take 5x squared minus 11x plus 4 and set it equal to 0 to find the zeros. Now we have a coefficient here that's not a 1, so we'll use this. 5 times 4 is 20. And we put a negative 11 down here. What multiplies to make a positive and adds to make a negative? 2 negatives. What multiplies to make 20 and adds to make negative 11? We got 10 and 2, that's not going to work. 5 and 4, that's no good. Let's see. Let's make sure I've got this right here. Yeah, everything's right. We've tried all the factors. It's not working out. So what did we used to do when we had a quadratic that we couldn't factor to find the zeros? We developed the quadratic formula. So we'll use the quadratic formula, and I would not count it against you at all that you don't remember the quadratic formula. If you do, it's very good and very useful. But I would expect most people just to look it up. So you got negative b plus or minus the square root of b squared minus 4ac over 2a. So that's what you would find if you looked it up. And so we're going to use that here. Let's use a different color. So our zeros are going to be negative b, that's going to be a positive 11 now. Negative 11 is positive 11. Square root of b squared, that's going to be 121. Minus 4 times 5 times 4 over 2 times 5. It's 11 plus or minus the square root of, okay, so we got 121 minus 4 times 5, that's 20, times 4 is 80. So we have 80 here. So 121 minus 80 is going to be 41. Over 10. Okay, and there you go. There's your other 2. 2 because 1 can be found by adding the square root of 41 to 11 and the dividing by 10, and the other can be found by subtracting the square root of 41 from 11 and dividing by 10. So just leaving this the way it looks, you have said these are the other 2 zeros of this polynomial. The first one was negative 2, and we use that to find the other 2. Okay, we'll do one more, and we've run out of room, so we'll delete everything. And we'll do number 36. There's a picture of this box, or what we call in math a rectangular prism. Right, this side is x plus 2. This side is x plus 4. What's this side? That's the question. Okay. Well, what they're telling us is the volume can be found by this expression, 2x to the third plus 17x squared plus 46x plus 40. Okay. 2 ways to solve this come to mind, so we'll just do both of those ways. So what we have is an expression for the volume and a question of what does this side, what expression represents this side. This one is x plus 2, this one's x plus 4, and this one is question mark. Okay. Well, first, the very helpful piece of information that will get us through this is that to find the volume of a box, you just multiply all the sides together. Length times width times height. So if we multiply x plus 2 by x plus 4 by question mark, we should get this, right? So x plus 2 times x plus 4 times question mark should equal this. So it should equal 2x cubed plus 40. That polynomial there. So we want to find question mark. Well, let's divide x plus 2 and x plus 4. Plus 4. Right, that cancels out these common factors, and when we divide this by x plus 2 times x plus 4, we should get question mark because now it's by itself. So how to do that? Well, in my mind, I'm thinking, well, we'll just use long division. We'll do it all at once. So that's what we'll do. We've got x plus 2 times x plus 4. That's x squared plus 6x plus 8. Okay, so we'll take x squared plus 6x plus 8, and we'll divide it into 2x cubed plus 17x squared plus 46x plus 40, and we start doing long division. So we're going to multiply x squared by to get 2x to the third. We multiply by, let's see, 2x. Yes, multiply by 2x. Okay, so 2x times x squared is 2x to the third. 2x times 6x is 12x squared. 2x times 8 is 16x. And we subtract everything here. 2x cubed minus 2x cubed is 0. 17x squared minus 12x squared is 4x squared. 46x minus 16x is 30. Right? Yes, it is 30x. And then we bring down the 40. And we go through this again. X squared times what is 4x squared? That's 4. 4 times x squared is 4x squared. And that's what we're doing next. 4 times 6 is 24x. Let's see. What, I have done something here. Yes, I have done something wrong here. Let's back up. We'll go up to here. Back to the step where we said 17x squared minus 12x squared. That should have been 5x squared. So how does that change things? I think everything else should be fine. So the next thing that we are going to correct here is we said x squared times what is 5x squared. That should be a 5. Okay. So that'll change things again. 5 times x squared is 5x squared. And 5 now times 6 is 30x. Okay, so those are the corrections we've made. And now we should be able to continue. 5 times 8 is 40. And we need to subtract. 5x squared minus 5x squared is 0. 30x minus 30x is 0. And 40 minus 40 is 0. So this is all that's left. 2x plus 5 is question mark. Okay. So maybe you don't like that. Maybe you like long division or synthetic division, which we can use. We could start by just dividing by x plus 2. So we'll do 2, 17, 46, and 40. And we'll divide by x plus 2, like I said. Put negative 2 there. Bring down the 2. Negative 2 times 2 is negative 4. Okay, so then we get 13. Negative 2 times 13 is negative 26. 46 minus 26 is 20, and negative 2 times 20 is negative 40, and we get 0. Okay, so we get this, what this means is 2x squared plus 13x plus 20 is the result of dividing this by x plus 2. So we could take this guy here now and put it into synthetic division. And we'll now divide by x plus 4. So put the negative 4 in there. So we'll divide out that factor and see what's left. Bring down the 2. We get negative 8. We get 4, 5. Negative 20, 0. So we get 2x plus 5. Okay. So it's up to you. This one takes quite a bit more understanding, more fluid thinking to understand that we could just divide this by x plus 2, then we could take the result of that, but divide that by x plus 4 and get the result. And that would be the same as just dividing the whole thing by x squared plus 6x plus 8. Okay. But either way that you decide to do it, we see that we just need to divide this x plus 2 and x plus 4 out of this volume expression to get this length here. Alright, well, thank you for watching. I hope that was helpful.